In this problem, we're going to determine whether the given function is one-to-one. So there are a couple of ways you can do this. The first way I'm going to show you is with a picture, so let's split this in half here. So if we want to draw a picture of f of x is equal to x to the fourth plus 4, we want to go ahead and put down an x and a y-axis. And basically, anytime you have an equation with an even exponent, so like x to the fourth is even, it's going to look something like a parabola. So its general shape looks something like this. Okay, now the key to this is that we've now restricted our domain to only positive numbers. So actually what I'm going to do is erase the part of this graph that had negative numbers, and now we can see that we have this resulting sort of half parabola shape. Okay, so now since I've drawn a picture, I can use the horizontal line test. So remember that the horizontal line test is very similar to the vertical line test. So like we put a pencil on our paper, and basically what we want to do is draw horizontal lines and see how many times they cross our blue curve. So we see each time, each line only crosses the curve at a single point. So what this means is that we pass the horizontal line test, okay? So if we pass the horizontal line test, then the function is one-to-one. Okay? An example of failing the horizontal line test is, imagine if we had a whole parabola like this. So if we were to draw horizontal lines here, see, it would cross the curve more than once. So this would be an example of a fail. So again, this isn't our problem, but it's just an example of a fail of the horizontal line test. Okay, so we'd say this one passes. Okay, another way you could determine whether it's one-to-one is you can use the equation. So what we can do is we can take the equation twice, set it equal to each other. The first time we plug in A, the second time we plug in B. So that might have been a little confusing. Basically what we're saying is we assume that f of A is equal to f of B. So what this means is we plug in A on the left, so we have A to the fourth plus 4, and we plug in B on the right. So we have B to the fourth plus 4 on the right. And then what we want to try to get to is that A is equal to B. So we want to try and solve this equation down until we get that A is equal to B. So first of all, I could subtract 4 on both sides, and I would get A to the fourth is equal to B to the fourth. Okay, the next thing I want to do is get rid of those exponents, so I could take the fourth root of both sides, which would give me plus or minus A is equal to plus or minus B. So remember, when you take the even root of a number, you always want to include that plus or minus with your answer. So now the question is, how do we get from this plus or minus symbol to only positive A and positive B? Well, this is where the restriction of our domain comes back in, because we know that x has to only be between 0 and 7. We know that it can't be a negative number anyway. So basically what that means is we're going to disregard the negative sign that we wrote here. So it's like we just erase it, and we're just left with A is equal to B. So this means that f of x is one-to-one. So those are two different ways of working the same problem. One's more formulaic, and one is more visual. For this next problem, we're going to use the inverse function property to determine whether f and g are inverses. So remember that the inverse function property is the following. So we say if f of g of x is equal to x, which is equal to g of f of x, then f and g are inverses. So basically what this means is we want to check two composite functions. We want to check f of g, and we want to check g of f, and if we can simplify them both down to just x, then the two functions are inverses. So let's do that. So first we'll find f of g, so we're going to plug g into f. So we'll have 3x plus 3 over x minus 1 plus 3. That's all the top of our fraction. And then we'll have 3x plus 3 over x minus 1 minus 3. And now we just have to simplify this horrible fraction. So on the top, we can get a common denominator of x minus 1. Since this first fraction already had that denominator, it's still going to stay 3x plus 3. And since this second number was missing it, we're going to multiply it by x minus 1. So the top of the large fraction becomes 3x plus 3 times x minus 1 all over x minus 1. And we want to do the same thing on the bottom. So we're going to get one big fraction over x minus 1. The 3x plus 3 stays the same because that was already our denominator, was x minus 1. Now for the negative 3, we're going to have to multiply that by x minus 1 because we didn't have that in the original denominator. Okay, so let's divide these two fractions. So we have 3x plus 3 times x minus 1 all over x minus 1. And for that bottom fraction, we can flip and multiply. So we'll have x minus 1 over 3x plus 3 minus 3 times x minus 1. The x minus 1's cancel out because we have one on the top and one on the bottom. And so we can say that this is 3x plus 3x minus 3 all over 3x plus 3 minus 3x plus 3. So let's see what happens here. So on the top, we can add 3x and 3x to get 6x. 3 minus 3 is 0, so those are going to cancel. On the bottom, 3x and minus 3x cancel out. And we have 3 plus 3 is 6. So if we do this final division, 6x divided by 6 is just x. So this is good, but we're not completely done. So if you get x for one side, you still have to check the other side. So now we'll do g of f of x. So this time we're going to plug f into g. So we'll have 3 times x plus 3 over x minus 3 plus 3. That's the top of our fraction. And then we'll have x plus 3 over x minus 3 minus 1 as the bottom of our fraction. Okay, so now we just have a bunch more algebra to do. So first of all, let's multiply on the top. So 3 times x is going to give us 3x. 3 times 3 is going to give us 9 over x minus 3 plus 3 all over. And now let's go ahead and get a common denominator for the bottom. So we'll have x plus 3, and all of this can be over x minus 3, and we'll have to multiply the negative 1 by x minus 3. And then we can do the same thing for the stuff on the top. So we'll have one big fraction over x minus 3. 3x plus 9 stays the same, but then we'll have 3 times x minus 3. So let's see here. We'll have x plus 3 minus x plus 3 all over x minus 3. Okay, so now we're in the same case as the previous one. So we have a fraction divided by a fraction, so we can flip and multiply. So we'll have 3x plus 9. I'm going to go ahead and distribute right here. So we'll have plus 3x minus 9 over x minus 3 times x minus 3 over x plus 3 minus x plus 3. The x minus 3's cancel out. If we add the things on the top, we'll have 6x, and the positive 9 and the negative 9 cancel out, so we're just left with 6x. And on the bottom, the x and the negative x cancel, and we're left with 3 plus 3, which is 6. And if we do 6x divided by 6, we're just left with x. So that's good. Both sides work, so your conclusion should be f and g are inverses. Okay? For our last problem, we're going to find the inverse function of f. So f of x is 2 minus x squared, with x greater than or equal to 0. So the reason we include this is because normally this graph of f of x would be a parabola, which we know is not 1 to 1. So the only way we can find an inverse is if our function is 1 to 1, and so that's what this little restriction right here does. That's all it does. So let's set about finding an inverse. So the first thing we want to do is write our function with a y instead of f of x. So we'll write y is equal to 2 minus x squared. And then we want to flip-flop the position of x and y. So we'll rewrite x is equal to 2 minus y squared. And then we want to solve for y. So we can subtract the 2 over. So we'll have x minus 2 is equal to negative y squared. We can divide by the negative sign on the right. So we can say 2 minus x is equal to y squared. And finally, we can take the square root of both sides. So we'll have the square root of 2 minus x is equal to y. Okay, and I believe WebAssign already gives you the restriction, so you should have like x is greater than or equal to 2, I believe. Yeah. Less than or equal to, my bad. Okay, but I think WebAssign gives you that already. But again, this part right here is not super important. That's just ensuring that our function stays 1 to 1. All right, so that's the end of 2.8. If you have any questions, please let us know.